All right. Oh, let me change the screen. It's going to zoom in on me. There we go. So when we're trying to put it in degrees, minutes, seconds, we're really kind of just looking at those decimal pieces. So we're going to keep this as 126 degrees. But we're going to take our 0.5414 degrees, and we want to get that down into the minutes situation. So what are we going to multiply it by? 60. Times that 60. And that's our 60 minutes to our 1 degree. If you think of it as unit conversion, what's that going to give us? 32.484. This gives us 32.484. Minutes. So we're going to have our 32 minutes, and we're going to do the same kind of vibe with this decimal. We're going to take our 0.484 minutes, and we're going to convert that into our seconds. So what are we going to multiply that one by? 60 again. Our 60 seconds to our 1 minute. What do we get when we multiply that? It's entirely possible, but I was going to say mine, I was getting 29.04, but it's entirely possible that I typed something in wrong. What'd you guys get? 29.04. So if we're rounding to the nearest second, what is this in degrees, minutes, seconds, the whole thing? 126 degrees, 32 minutes, and 29 seconds. Seconds has 2 lines.
Why did you multiply by 60?
Because our 1 degree is 60 minutes, and 1 minute is 60 seconds. So if you think of it as like a unit conversion, you can do it like 60 minutes or 60 seconds to 1 degree. Sorry, 60 minutes to 1 degree, 60 seconds to 1 minute, just like if I did feet to inches. 1 foot is 12 inches. So if I have 2 feet times 12, that would give me the number of inches. It's a unit conversion kind of deal. And we're going to practice this the other direction as well. I just didn't want to hop straight into going the other direction from what we did yesterday without remembering what the heck we did. Okay. So being able to put it in degrees, minutes, seconds is going to be one of those things that pops up every now and then. It's not going to be something we do a gabillion times. Mostly it's in this first section. But since we went this direction, we are also going to try going the other direction and get it back to a decimal. So we're going to get to the nearest 10,000th. So that is our decimal place. That is going to be our tenths, hundredths, thousandths, 10,000ths. So 4 decimal places. That's what we're looking for here. So if I have 17 degrees, 46 minutes, and 13 seconds, we're going to try and get this back to being just as a degree decimal. So we've got our theta here. And again, it's kind of easy to think of it as a unit conversion. There's a couple of different ways you can go through it, but it's mostly a unit version. So I'm just going to drop down the first 2 pieces to start. So we're going to have our 17 degrees and our 46 minutes and our 13 seconds. If we think of 13 seconds, and I want to get that to be minutes, 1 minute is 60 seconds, right? So we could write this as 13 over 60 minutes. Yes. I've got a couple of like terms. I've got 2 sets of minutes here. Get this as a decimal. 13 over 60. So this is the same thing as our 17 degrees And 46 plus 13 over 60. Is going to be 46 point. What is 13 over 60? Mm-hmm. I'm going to take 4 decimal places. 2167 minutes. So I've taken and we've gotten rid of the seconds entirely. Same vibe. Getting rid of the minutes down to degrees. So in order to get minutes to leave, I need to take the fact that 1 degree is the same as 60 minutes. So good at notation. So I can get rid of the minutes here if I take my 17 degrees and we're going to add on our 46.2167 over 60 degrees. So it's still going to give us a decimal again. It's just going to be kind of icky. So as a degree, what is this going to be? 17 point what? 77, 4 decimal places. 03 degrees. And that's our theta. So it's going the opposite direction. And what we're really doing here is we're really adding those pieces together. 17 plus 46.2167 over 60. Okay. One more like this where we're just unit converting it. Same kind of vibe. I'm going to take my 41 seconds and make that minutes by dividing it by 60. So we're going to have our 72 degrees, 63 minutes, and my 41, bless you, over 60 minutes. Because we're going to take our seconds and convert them back to minutes. So our 72 degrees. And what is our minutes as a decimal? 6833 minutes. Converting it back to degrees, what are we going to get?
613.
So our total, our final unit is going to be what? 73. It changed our degree here because they improperly marked this. This is 63. There should only be 60 minutes in a degree. So this has an extra degree in here. So we're going to have our 73.061, and I believe it should be 4 with rounding to our 4 decimal places, degrees. I'm going to scooch that down a line just so it can give us a mid-step, just because I like to have it there. Our 72 degrees plus that fraction that has our 63.6833 over 60 degrees.
What do you mean that it was improperly marked?
So when we talk about how our units up here are 1 degree is the same thing as 60 minutes, right? 63 minutes. Yes, sir.
Is it fine if we notice that it's 63 and just change it to 70?
Totally fine. Simplify in whatever order you choose. Yes, dear.
Can I get a calculator?
Yeah, absolutely. Calculators are back there by the flag if you ever want to use one of mine. There will occasionally be times when we are not allowed to use it or when we're gonna like make it so it doesn't actually work. And I'll let you know when those are, but these are super calculatory. We're gonna use calculators on this part. So there will be portions sometimes of test quizzes where we don't use calculators, but mostly it's because those are gonna be things we can do in our head or that I need you to not rely on the calculator for because we need to have it memorized. But it's not super common. All right, questions on these two? All right, so what we're gonna do is we're gonna find our supplementary and complementary angles here. We talked about this yesterday a little bit. Complementary is when they add up to be what? 90. And supplementary is when they add up to be what? 180. So for this theta of 23 degrees, what is going to be our complementary? We want to know 23 plus what? I'm going to use a Greek letter because we're talking angles, is 90. So our angle is going to need to be 67 degrees. You can use whatever letter you want. If you want to use X, that's fine with me. But I'm going to use Greek letters. How about our supplementary? Because we're looking for our 23 plus what? I'm going to give it a different letter, so I'm going to call it alpha, is our 180 degrees. That's what makes it supplementary. So that angle is going to need to be 157. That gives us a supplementary. That's the way, like the way we did them in geometry. Sometimes we're going to get them when they've got our degrees, minutes, seconds stuff. This is when it helps sometimes to write them in that improperly simplified way. We did it the other day, we did it yesterday when we were talking about 90 degrees with our degrees, minutes, seconds. Because what we're doing here on this 15 degrees and 49 minutes, looking for our complementary angle, which I'm just going to mark that as C. Oh, I love that I have them switched from the top, so let's just change a different color. So our complementary angle, that's when we have our 15 degrees, 49 minutes, plus something, I don't know what yet, equals our 90. But I've got those minutes, so the minutes doesn't super help when I've written it as 90, because we'd really like to just subtract it from the other side, right? Our angle is going to be that 90, but I don't want it as degrees. I want it as degrees and minutes. So I'm going to put this as 89 degrees, 60 minutes. That still equals 90. But to get our beta by itself, we're going to subtract our 15 degrees, 49 minutes. You see why it's a little more helpful to write it like this sometimes? Because to find our B, our angle here, we can do this in a couple of pieces. 89 minus 15, which is significantly easier to do. What is 89 minus 15? 74 degrees. And how about 60 minutes minus 49 minutes? 11 minutes. So writing it improperly simplified is sometimes really helpful.
Is it just like combining those?
100%. The reason we switched it to be this improperly simplified is because that gives us the like terms for the minutes. Otherwise, we have to do it, and it's all kinds of weird carry the one situation. Totally fine. Totally works to do it other ways. It's just, I feel like this is the easier way. So let's do the same thing for our supplementary. We're going to find when our 15 degrees, 49 minutes plus some other angle, I'm just using alpha here, equals our 180. That's what makes it supplementary. Again, I can do this with subtraction. Our alpha is going to be, and I can write our 180 improperly simplified as our 179 degrees, 60 minutes, and we're going to subtract that same number, our 15 degrees, 49 minutes. You're a good friend. So what are we getting for our supplementary angle here? Mm-hmm. 164 degrees. And 11 minutes. Okay. Questions on these two? All right, we'll do one more. So I'm adjusting the page a little bit because it had 2 on there, and I'm like, I don't feel like we need 2, and I'd rather have more time to talk about other things. We're gonna do this one. So this time we've got degrees, minutes, and seconds. So when we're finding our complementary angle and our supplementary angle, we're gonna have to include all 3 pieces. So to find our complementary angle, you can either do it as the addition and then subtract on both sides. We can just straight up go into the subtraction. I want to know when our 90 degrees is going to be met with this guy. So I can take my 90 degrees and subtract it, but since I have degrees, minutes, and seconds, I'm going to write my 90 like that. We're going to have our 89 degrees, 59 minutes, and 60 seconds. And we're going to subtract our given angle, our 54 degrees, 31 minutes, 10 seconds. So what do we get as our complementary angle for this one?
85 degrees.
Mm-hmm. Gorgeous. One more. 50 seconds. Same thing for our supplementary. Same vibe. But instead of doing 90 degrees, we're going to do our 180 degrees. So we're going to mark it as our 179 degrees, 59 minutes, 60 seconds. This still adds up to 180 degrees because this is the same thing as 1 whole minute. This is the same thing as 1 whole degree. But when we take away that given angle, minus our 54 degrees, 31 minutes, and 10 seconds, what do we get as our supplementary angle here?
125 degrees.
Gorgeousness.
9
Mm-hmm.
and 50 seconds.
And 50 seconds. Okay? So we're feeling okay on complementary, supplementary, that kind of vibe? Cool, cool, cool. Because the next piece is going to go into some different things. We're still going to be living in the world of degrees for now. But we're going to talk about different angles of rotation. So this is called angles of rotation in standard position. We're going to talk about positive angles and negative angles. We're going to do several little quick sketches I have, if you guys want, some little graphic things that we can use. I'll pass them out just because if you want them, you can use them. You don't have to use them. We're going to be looking at some circly stuff. It's different than the graphs that are out there. Those of you that have never had me before, I will always give you guys graphs when we get to graphing things. You don't have to use them. I will never, ever check your notes or notebook. Notes are for you to use. In the boxes on the table, there should be scissors and glue sticks. The glue sticks die semi-regularly because I think they're like 5, 6 years old. If I pull them out of the storage closet. So there's scissors and glue sticks in the boxes. If the glue sticks die, let me know. I have tons of extras because they just have stash them. You don't necessarily have to use those, but we're going to talk about positive angles and negative angles in terms of like a circle. I'm going to draw it by hand up here just because I didn't put it on the slide. Ooh, I am so good at drawing straight lines, y'all. Oh my gosh. We're just going to rock with it. I am so good at art. Oh my gosh. All right. So I'm just going to give myself a little circle. It looks just like yours. I am so good at art, y'all. It's really funny is I'm actually married to someone with a fine art degree. I can't draw. I can draw nothing. Nothing. All right. So we're going to talk about angles in standard position, which means we need to know what the heck our standard position is. Our standard position is based off of the x-axis. So our starting place is almost always going to be right here. Occasionally it'll come off the other side, but more often than not, it's going to be the positive x values on the x-axis. And positive angles go counterclockwise. That also only works if we know how to read an analog clock, like one of those guys. What that means is think about our positive angles go for our positive y values. So positive angles go this way. So this would be a positive angle over here. This is one, so it counts upwards. So that's how we get our positive angles. This would be a positive. Negative angles go clockwise. Again, think of it being like negative y values. It goes down. These would be negative angles. So they can have the same value. It could have like a positive 120 and a negative 120. That would be what these should be. So this would be about 120, positive 120, negative 120. It's the same angle, it's just the opposite direction. And then we're going to talk about something called a coterminal angle. And all that means is that they wind up at the same spot. So instead of me having two separate angles, if I was looking for a coterminal angle, I could start down here and come all the way up to the other side of this purple line, and they would be coterminal angles. They have the same start side, same initial side, pink, and the same terminal side, the same side where they end. So this is our initial side. This is our terminal side. I'll write those out just so we see them. And we're basing these almost always off of a graph that we're going to be looking at here. So we're going to sketch some angles and we're going to find some coterminal angles here on our next page. So it's kind of like thinking about complementary and supplementary. Complementary goes to our 90 degrees here. Supplementary goes to a straight angle or a 180 here. If we're looking at this whole circle though, how many degrees are in this whole circle? 360. So our coterminal angles, it's very much like a complementary gets us to 90, supplementary gets us to 180. coterminal gets us all the way to 360. So same kind of vibe there. So we're going to sketch some angles. We're going to find a positive and a negative coterminal angle. So I'm going to give myself a little bitty graph here. And we're going to sketch 60 degrees. So first thing I want to do is I want to figure out where positive 60 degrees is. Our initial side is always going to be our x-axis here. Positive angles, we're going to go up. So 60 degrees is going to be in which quadrant? 1, 2, 3, or 4? 1. And it's going to be about 2/3 of the way. We're just kind of eyeballing it. We are not going to use protractors. We're not going to get anything out like that. So this is about 60 degrees. If I want to find a negative coterminal angle, what is this going to be? Yeah, because we're taking our 360 minus the 60 to get that that angle is 300 degrees. But is it a positive 300 degrees? We went the wrong way around the circle. So this is negative 300. So this angle is negative 300. Negative 300 degrees and 60 degrees are the same angle. It doesn't matter which direction we go. So to find negatives, we're going to be subtracting it. Did I just hear I'm lost? I try and catch it when someone says something like that. So if I want to find another angle that exactly matches that, I'm going to switch my blue to be a little bit smaller real quick. Just making it smaller. Whoa, wrong pen. So this is our 300. What if I want a positive angle that's going to have the same initial side, same terminal side, but a different number to it? What could I do? Positive 300 is a thought. That'll get us down over here. But I don't want to stop right here. I want to keep going. I can take a 360 and go all the way around the circle and then go another 60. And then get right back up at that same terminal side. Because if I just go 360, I'm just going, whee, I ended up right back where I was. I want to still get up to my 60 degrees. So we still need to make that turn. So we're going to go all the way around the circle. And we're going to take our 60 degree angle that we started with. And we are going to add 360 to get to a positive, and I did that in the wrong color. Sorry, I like to try and keep my stuff colored. So if we add 360, that's going to give me another coterminal angle. So it's going to give us 420 degrees. Is the same exact thing as 60 degrees. I just did a twirl before I stopped at 60. Same thing. I could do the same thing the wrong way, around the circle negative. I could take my negative 300 and go around the circle again and do negative 660. Would still wind me at that same spot. So let's do that again for the next angle. Which I'm going to do this one in red. So if we think about our little angle, and we start here, the positive angle of 250. We got to figure out where that's going to land. If we think of this one as 0, what angle is up here? 90 degrees. What angle is right here? 180. What angle is this one? 270. that help us see where our 250 is going to be? Yep, it's going to be right there in quadrant 3. So this is my terminal side. This is what we're looking for. Angle 250 started here and ended here. So to figure out my negative angle, to find out what this equivalency is, we can take our 250, that angle, and subtract the whole circle. We're trying to figure out what that little cutout piece is. So minus 360 gives us what? What is that little angle going to be? It's negative 110. So this little guy right here is negative 110. To find our positive coterminal angle, we're going to take a different color pen, and we're going to do a twirl all the way around, and then come back to our terminal side. So we're starting at the same place, we're ending at the same place, we're just getting a little fancy in the middle. So we're going to take our 250, and we are going to add a circle. So we're going to add a twirl, add 360 degrees. 610. So we should get at 610 degrees. I should have had degrees on all of these. Just forgot. There we go. Okay, so positive and negative coterminal angles. Questions on those ones? Okay, let's do one that starts out with a negative. We're still going to find a positive and a negative coterminal. So we want a positive angle and another negative. So again, I'm going to draw myself a little circle. You don't have to draw the circle if you don't want to. If you just want to put it on your little, on the paper and do it like by hand sketch, totally fine. We're just kind of sketching them out, just trying to give us the tools we have. So if we're looking for our negative 100, where's that going to be? Quadrant 1, 2, 3, or 4? 3. Just barely off of our y-axis here. Because we go down from the x-axis. This is our negative 100. That's what makes it a negative angle. It goes down. So what is a positive angle that will be coterminal? We're going to take our negative 100 plus 360 to get another positive value, and that's going to be 260 degrees. Degrees. To find another negative coterminal angle, we're going to take our negative 100 degrees, and we're going to go all the way around the circle. So we're going to subtract 360 degrees. We're just twirling in the opposite direction here. So what is our negative coterminal angle? Negative 460, because this is 100. It was like you kind of smushed together the last two. That's all it is. I was like, I know you know how to do that math. Didn't I? Okay. Cool. All right. I'm going to put up our definition for tomorrow that we're going to start with, because we have another way of measuring angles. We've been living in the world of degrees. Degrees are great. We're very comfortable with degrees. Degrees are only so awesome math-wise because they're not super duper accurate when it comes to things like sine and cosine and those kind of guys that we're going to work with a whole bunch this semester. So we're going to use a whole lot of a unit called a radian. You're going to live in the world of radians a lot. So it's another way of measuring angles. It's called a radian. And it is based on the arc length and the radius, which is weird. I'm going to give us a little visual of it real quick while you guys are writing it down. I know you guys are oftentimes definition folks. Grab them on my left side, so we'll reverse it. Okay. So, what a radian is it's taking the radius of the circle. So I'm going to take my circle here. My radius is like this. And I'm going to go around the circle. So this is 1 radian. This angle. It's a way of measuring the angle. So if I take that radius again and I go another space like this, measuring that same radius around, we get another radian. So this would be 2 radians. Radians do not have a little symbol like degree does. Degree always has that little circle as an exponent. Radians are just written up straight up as a number. So that's why I went back and added all those degrees in there. So if I did that again and got to a 3rd radian, the 3rd radius, what color? That's going to fit right about here. So this would be a 3 radian angle. It's relating our circumference, or our arc length, technically, to our radius. How do we relate the radius to the whole circle? Like, how do I find the circumference of a circle? Do you guys remember? 2 pi r. So the whole way around the circle is going to be 2 pi times whatever our radius is. Well, if this is 1 radius, 2 radius, 3 radius, this is 2 pi radiuses. So this is 2 pi, goes all the way around. So if we go halfway around, pi radiuses. So 1 radian, 2 radians, 3 radians, pi. We are going to work with this bunches and bunches and bunches. We will play with this a whole lot more tomorrow. And yeah. We will probably be okay time-wise still for the homework to be due the day it's listed, but I'm reserve the right to push it back if we don't quite get there, okay? So we will work more with radians tomorrow, and I will probably do that whole bit again just to talk it through so we see it before we go through it again. But just one of those, sometimes it's easier to see it twice than to only see it once and just hop straight in. So, oh, definitely not 1/9. Definitely not due tomorrow. It has radians on it, so definitely no. I was like, I even think I have it written on the board as 110. That's still, we didn't have a snow day dates. So do 110 at the very earliest. I reserve the right to push that back if we need to. Okay? I will only ever push backwards. I will never say, hey, we got it done early. It's due early. No, that's mean. I don't do that. Even if we get done early, we will just keep going. Okay, please do not forget to register for the IU section of this class before we get to February. I will continue to remind you. It will continue to be annoying that I do so. There is a link on the Canvas page right under the IU banner that will get you to the page directly. I also have made a tiny URL that gets you to the registration page. You have to sign up for the IU portion or you don't get the IU credit, and in which case, why are we doing the extraness? Oh, you can leave them on the desk. My next class is Precal too. Okay? So we will work with radians a lot tomorrow. Looking at the homework, there are radians mixed in. If you see anything that has a pi, that's a radian. Degrees will always have the little exponent circle thingy, the little degree symbol. So if it's got a degree it up. If it has no little degree, put a chill pill on that and wait for tomorrow. We'll talk through the radians tomorrow. Okay? You have less than a minute to the bell, but I didn't talk until the bell. Yay.